Greetings and welcome to the STEM CTL acronym for Center for Teaching and Learning and Engineering by Design Middle School Overview. My name is Ryan Novitsky and I'm the STEM CTL Director of Learning. My contact information is listed below, so at any point if you have any further questions, you can feel free to email me at any time at rnovitsky@it.org. And if you'd like to follow along with the presentation on your own or look it up a little bit later at a time, there's a QR code as well as a bit.ly located on the first slide on the next few. Our objectives for this presentation are to analyze Engineering by Design Middle School coursework and overview STEM Center for Teaching and Learning, acronym CTL, initiatives. On our agenda for today is to introduce Engineering by Design. Well, what is it? We'll go into a little bit of detail about Engineering by Design, introduce the newly revised STL to the STEL Standards for Technological and Engineering Literacy, a STEL lesson plan template, how to navigate through our media-rich edition via Buzz, Agilix Buzz, and the standard editions PDFs of our Engineering by Design courses, media-rich edition for all, some future initiatives around professional learning opportunities and growth via the STEM Center for Teaching and Learning CTL initiatives, highlight our ITEA 2022 Orlando Floral Conference, and also, if you have any inquiries, have a questions, comments, or concerns form, and who you can further contact outside of myself, specifically in the state for North Carolina. If at any point, even after the presentation, you have a question or comment, feel free to fill out our form listed within this presentation. First, before talking about the individual courses and a couple navigational points on our middle school content, let's first talk about, well, what is EbD? Engineering by Design is a pre-K through 12 curriculum that offers content from pre-adolescence up to secondary education. We reach out to pre-K to 12, but it isn't to say that if you don't take a course to elementary level or the middle school level, you won't be successful at the high school. The courses are built in a way that are equitable, achievable, and reachable by all. You can scale the courses up or scale it down in order to meet the teachers' and students' needs in the everyday classroom. Engineering by Design, ultimately, is a program that is built on the belief that the ingenuity of children is untapped, unrealized potential that, when properly motivated, will lead to the next generation of technologists, innovators, engineers, and designers. Although we hear the word engineer quite frequently in our content and curriculum, it is not to say that the students have to become engineers via our content. We help to give students the problem-solving, analytical thinking, and critical analysis techniques in order to be successful post-secondary education or going into the high school or going into the middle school setting or going after the preschool setting into kindergarten or other elementary grades. When I left-click on what is EbD, it gives a little more in-detailed presentation of what Engineering by Design is. So I'm going to take a moment to overview this presentation. This is considered our essentials. All of our content is built around an integrated STEM educational approach. It utilizes all four disciplines within the acronym for Science, Technology, Engineering, Mathematics directly within our content. The definition is as follows on the slide. North Carolina is a EbD consortium state, like in our center right there. You are headed by your state director, Ms. Kim Forbes, in that access to content and curriculum is supplied to every single educator in your state free of cost. We help the STEM Center for Teaching and Learning to develop content and curriculum, such as Engineering by Design, use assessments to make informed decisions, use research to further decisions, and also we offer professional development and learning opportunities. Engineering by Design is driven through national and international standards. Our umbrella standard being the Standards for Technological and Engineering Literacy, which is hyperlinked to resources for the standards for technological and engineering literacy. Also, we are driven by other national standards such as the Common Core, NGSS, Grand Challenges for Engineering, Engineering Habits in Mind. We'll talk about this graphic in the next couple slides as well too, as far as a sequence of learning. In the middle school curriculum, we have 6th, 7th, and 8th, as well as a Nationally Science Foundation backed course called Engineering for All around vertical farming, as well as the World in Crisis for water. We use a 6E Learning by Design model for all of our curriculums. Whether it's pre-K, 12th grade, 9th grade, 6th, 7th, or 8th, we utilize a 6E format. Sometimes these are mistaken for an accepted model for the 5Es that are used in CT courses or through ACT, or what is sometimes even accepted by a Danielson model. But we are not based off of it. We are based on utilizing this as a framework to help to drive our learning cycles. We use the engagement portion, which is kind of get the students interested in what is going to be taught throughout the next several classes and where you want them to learn gives an indication of where they currently stand in your classroom. Exploration phase, in which they're trying to go through and understand what the topic is going to be prior to kind of engaging in it. Explanation is the teacher is taking the time or the options and opportunities to kind of go through and detail things for the students. Engineer with little e, to provide students with that extra opportunity to get a better understanding by a PBL, problem-based, or PJBL, project-based learning towards becoming affluent in applying concepts, practices, and attitudes through applied learning. Enrichment, which is taking it to the next level for students, giving them further opportunity to learn more in depth on a particular concept. This may not always be touched on or hit during a particular lesson, but it gives the option towards that further enrichment. In all of our content, we offer evaluation phase to evaluate, or which is assessments via thumbs up, thumbs down. It could be just check for understandings, looking over engineering journals, rubrics, design brief reflections, brief constructive responses, reflections around literacy, etc. Many different ways to evaluate and assess the students. In addition to that, we do offer pre and post assessments, which enable the educators to gauge the students via test analytics around where the students currently are at the beginning of a year and at the end of the year, and showing the overall growth from beginning to end for the students to show did they actually achieve mastery of learning. It shows particular questions that were not answered properly or were incorrect or correct, shown through different charts, and can be also projected out for utilization because we do use an LMS called Agilix Buzz. It is a true LMS or learning management systems. As mentioned before, the STEM Center for Teaching and Learning is involved in research, and we also mentioned that the Water and World and that additional middle school curriculum was backed by NSF. There are also some other projects that were going on and have finalized via soft robotics that are now used in the Advanced Technological Applications course, and it was piloted with the Foundation of Technology students around hard robotics, but they added in and expounded upon it on soft robotics. The contacts for our ITA staff that help to lead the Center for Teaching and Learning is Mr. Steve Barreto, our Executive Director, myself, Director of Learning, Rebecca Turner, our Curriculum Coordinator, and Joe Fleming, our Technical Support Coordinator. These courses are built in a way, though, if you didn't take a middle school course, will you be successful in our high school courses? Yes. If you didn't take an elementary course, will you be successful in the middle school courses? Yes. You don't need to take an elementary EbD course to be successful in our middle school content, or 6th grade even before 7th, or 7th grade before the 8th. They're, again, as mentioned before, they're reachable by all students. And they do, although build upon skill sets, it doesn't say that it builds upon individual learnings or something that's taught specifically in that course. You need to know that before the next course. That's not how our courses are built out. When going towards the high school level and when at the middle school level, starting to think about that in the future sense, we are actually offering industry certification pathways. more pertaining towards high school students. So if you wanted a chance to kind of look over a couple different PDFs as far as industry certification pathways linked up here for Autodesk, or our October release for the future Onshape, PTC Onshape certification individual course. We're also going to be embedding it within one of our middle school courses, Technological Systems. It's already in our Inventions and Innovations course as well too. So we use Onshape at the middle school levels, and it helps to kind of bleed and go over into the high school. So if you have an opportunity to kind of see where are those students going to go towards after middle school, click on the link up here, how to get some further training on it, Autodesk University, reach out to us, or you can also check out the Onshape, PTC Onshape certification. Some software is utilized or recommended for all middle school courses: AutoCAD, Tinkercad, Onshape, Revit, and Inventor. We do not require you to use one over the other. Although on the prior slide, it mentioned certification pathways, that is not to say that individual certification needs to be obtained. It is the educator's autonomy to choose the programs and the pathway for the students in the best interest they believe the students will be at that level for their classrooms to move forward towards mastery of the student learning for objectives and standards. There's several links embedded on this slide too to go towards those individual programs. The standards for technological and engineering literacy are the umbrella standards that help to drive all of our content. All of our content is being revised to align with the standards for technological and engineering literacy, as well as the ISTE standards and the NAPTEL embedded within our content. But the STEL drive it all. Embedded within this PowerPoint is a small promo video to help to show a little bit more of understanding of the STEL, which I'll show in a minute. There's an archive seminar on the STEL, which is a professional learning hour that was offered during one of our monthly seminars that'll help you give an in-depth description on what the STEL are. There's a presentation embedded within here and further resources. In order to implement the STEL standards within your content with fidelity, we have devised and created a STEL lesson plan template. On the fourth bullet down shows a video tutorial that walks you through how to use lesson plan template. It is online and fillable and suitable for all subjects. It helps you to effectively align with the STEL as well as other standards. When you choose a particular context area within the STEL lesson plan and indicate the grade band, it automatically populates all the other matching academic standards such as NGSS and Common Core ELA Math, followed by the benchmarks to match the standards for the cognitive, affective, and psychomotor domains. The online tools and more on the ITA website help to make lesson plan writing more efficient and better aligned with the STEL. Multiple other supports come along the way, help you align effectively with the STEL, and help to drive your lesson plans. As mentioned before, we are pre-K-12 standards-based content curricula. On this specific slide, if you are following along with the QR code or bit.ly, they're individually linked to go to at a glances. For instance, if I left click on exploring technology, or if I left click on invention and innovation, or if I left click on technological systems, you'll begin to see the 3 different courses at the middle school level. For the 6th grade course, Exploring Technology, it is meant for about a semesterized course, and there's some multiple focal points within the content. Meeting Engineering Technology with 4 different focus regions, and Design and Engineering. Meeting Engineering and Technology is engineering and technology impact every individual and society as a whole. Technology existing to solve problems through the use of creative solutions that work the best by demonstrating careful selection of resources to generate the best outcomes. Use of resources are a result of detailed and accurate plans based on ideas evolved through utilizations of the EDP, or Engineering Design Process, and Engineering Design Journal to ensure production of technology design solutions developed to achieve desired results. Inventions and Innovations is a semesterized course over the length of 18 weeks and is intended for grade 7. The individual KSBs, or knowledge skill builders, or is what they're referred to at the middle school level, are Introduction to I&I, or Invention and Innovation, EDP, Engineering Design Process, I&I in the design world, using design and creativity to help others, technology and society, and creating a space exploration infrastructure. Our 8th grade course, Technological Systems, again, is a semesterized course intended for the audience of grade 8. And the KSBs for grade 8, meaning knowledge skill builders, because the middle school level, when we show the Agilix navigational points, we do knowledge skill builders in middle school, not units like in high school. We talk about how systems work, technological systems, how to maintain them, interaction via technologically, and the systems in the design world. EFA are the extension units, or Engineering for All. This course length is approximately 14 weeks. I have also seen it extend over the course of a semester. It is a NSF-funded course that create, test, and revise 2 7-week modules for middle school technology education classes that are based around social context of food and water. One specifically focusing on fresh food for cities via vertical farming, other one focusing on water, the world in crisis, and how to improve water availability and safety overall. Let's go a little bit deeper though into individual courses for technological systems. First, I want to show what one of the courses looks like in our Agilix Buzz Learning Management System. When I go into Agilix Buzz in our Learning Management System, and then I look for individual courses such as Technological Systems, or our 8th grade course, go over some navigational points. When I left click on this caret, or I left click on that caret, or I left click on this one, or that one, they drop down into particular segments, such as our course description on what technological systems is completely about, our purpose, the overview, recommended course length, the connections to the program sequence, as well as a copyright agreement. Afterwards, there are several videos in here on best practices and safety practices on what to do in a standard laboratory used for technology, engineering, education. A welcome, which is talking about the EbD model program, which we've talked about already, the core program, the engineering design process that's utilized within the individual grade bands, like as K2, 3.5, and 6.12. When I left click on one of the links, it shows the EDP that's used for grade 6 through 12. There's national curriculum crosswalks that cross it over our content, TSA crosswalks, as well as credentialing and industry certification, as aforementioned in one of the prior slides. And then goes into a course introduction on technological systems, as far as the look and feel of the course overall, on the course outline. Then it goes into our course blueprint, which then says how much is a particular standard aligned within the course to what is being taught. For instance, standard 1, benchmark D. How heavily is it focused on, or depth of coverage? It says 2, so that means out of 4. It's focused a little bit, but not too much in depth on the individual benchmark within that standard. First 5 days, this specifically talks about what you as the educator and the students will be doing for the first 5 days of school. And then it goes into our KSBs. KSB is acronym for Knowledge Skill Builder, which in the high school, it's the units. We'll use Knowledge Skill Builders. What skills do you want your students to learn, and how are you going to engage them via the knowledge to build upon one another towards that particular skill? Within each KSB is our individual lessons. There's an overview of the lesson that's within that KSB, big ideas, purpose, a shortened lesson plan as well too via the 6E, going into our full-blown, full-tilt lesson plan. Then development of the systems, which is our supporting files right here too, which is our KSB 1 slides, our presentations, our assignments, our activities, and every single portion that's needed in order to be successful to teach that individual lesson within your classroom. So all resources are supplied within the learning management system. In order to get access into our learning management system, and again, being a consortium state, you have the opportunity to get access into the learning management system at either a free cost paid by your state, because there's licenses already pre-purchased, or there's discounts for your school. Well, how do you access it? Global STEM, STEM by state, left click on your state. Afterwards, as long as you're logged in and you're approved via your North Carolina email, you left click on EbD Consortium Resources. And afterwards, you'll see you get access to all of the courses that are being offered in your state of North Carolina, ranging from EbD teams, pre-K, all the way to secondary at the high school level. So if you were to go through and, for instance, click on one of the standard editions, scroll down a little bit, and let's just choose Exploring Technology, and then you download it. The look and feel of this PDF is navigation through it via a PDF. It takes a little bit to load up. And then once it loads up, you'll have access to the full course and curriculum, but it's not as user-friendly as the mentioned and shown learning management system. But the content via PDF is always free to all schools, pre-K-12, as well as getting access into that learning management system I just showed a second ago through Agilix Buzz. There's either free paid by the state or reduced costs for your school. Technological systems overall is intended to teach students how the systems work together. And as shown before in the at a glance, everything is based around systems in some way or the other. As you saw, each individual knowledge skill builder that were getting built out. Let's go into and just talk about what the units are. As we mentioned, they're all based around systems, how they interact, how they worked, how they get maintained, and also just overall how they are in the world. So really talks about and gets into the nuts and bolts of how they work together and how to maintain them once you know how they work, and then how they interact with one another. So they kind of build upon one another, and it is important to note that they should be taught in that sequence from KSB 1 and 2 and 3 and then 4. And again, as mentioned before, it's recommended to take after those 2 courses as far as exploring tech and I&I, but not required. We already showed the at a glance for technological systems, but it's also included in here. Let's start to go a little bit deeper into technological systems and overarching, well, how do they work overall? This is built directly into the coursework, meaning KSB 1 Knowledge Skill Builder around technological systems. It is completely around investigating through functions, design, development, interaction, and maintenance. The systems include exploring communications, construction, manufacturing, biomedical, and power energy. And the overarching purpose of this KSB, which again is similar to a high school, which is called the unit, but it's a KSB Knowledge Skill Builder, is to prepare students to understand and evaluate the design and development of systems overall. So technological systems, as even mentioned in the former at a glance, is all around a system building upon another system, how to maintain them, how to reconstruct them, and how to evaluate them overall. We also included some resources directly within this presentation to get a look and feel of what tech systems completely is about. One of our newly revised and rewritten courses is Inventions and Innovations. What's going to be different about our middle school content moving forward is the addition of preliminary and primary challenges. What it's going to look and feel like overall is what it looks like at the high school level. For instance, again, this is a high school course I'm showing now, but I want to show what's going to be different for the new Inventions and Innovations. They are going to have preliminary challenges and primary challenges added into the content. So a preliminary challenge will be in KSB 1 for Inventions and Innovations. A primary challenge will be in KSB 1 for Inventions and Innovations as well. And those help to gauge students' understanding via PBL and PJBL overall, or problem-based and project-based learning, via the hands-on learning. So preliminary challenge will be done first, and the learning cycles, finalizing with the primary challenge. So if I navigate though back to Inventions and Innovations overall, like for instance right here, what's going to be added into the KSBs will be individual preliminary and primary challenges built into the KSBs. But the look and feel of the LMS will remain constant. But the activities will be changed also. Activities are going to go to lessons, and it'll the same look and feel as the other middle school content that is being rewritten and has been revised to be launched in the next couple weeks. This course is exactly that, Inventions and Innovations. It's intended for 7th grade students, in which they will be learning all about inventing, which is making something new, and innovating, meaning change for the better good overall. They'll be studying the history of it, impacts in society, and really learning about the core of how important it is to understand when to innovate, when to invent, when to kind of recreate that wheel, lack of better terms. There will be different KSBs, but very similar in structure in regards to setup There will be the KSBs, the added and preliminary and primary challenges, and a focus on the same and similar topics of introductions, the processes, designing worlds, using design and creativity to help others, and tech and society. I also included some resources for inventions and innovations that are linked directly within the presentation, as well as our at a glance. And let's go a little bit as we go into the actual presentation itself. We'll notice that I also included our big idea, which is including creative ways to turn ideas into real things by inventing and innovating. What you want your students overarching to understand at the end of the day, at the end of a lesson, at the end of a learning cycle, and the purpose of the lesson. Several resources from the current content were included in here. And as we go and update the content next couple of weeks, you'll see different resources, but they're all standards aligned, going to very similar objectives and standards overall, but new standards being realigned and new coursework being added. As you mentioned before, we use a 6E learning by design, engineering by design model. There's an example listed directly on here for invention and innovations, how to engage students, to get them hooked at the beginning and kind of get that piqued interest, and how to evaluate them at the end of the day. We do offer the option, the autonomy for what is called a media-rich edition for all, which is a common cartridge. So essentially all the files are sent over to you. Once they're sent over to you, you're able to utilize those within your individual LMS. It is navigatable, we send them over, but you have to kind of set it up into your own learning management system. If you want that option, feel free to reach out to EbD Buzz support. We offer obviously our own LMS, as well as that PDF version. There are several different professional learning opportunities that are offered through the STEM Center for Teaching and Learning, or acronym CTL. If you're looking to take that future leadership jump or future leadership role and further within the EbD or Engineering by Design content and coursework, it would be of your best interest to look into becoming an authorized teacher effectiveness coach. You would become authorized to lead PD for a designated course in your consortium state or district. For instance, if your district leader, Ms. Kim Forbes, says, hey, is anybody interested to attend this ATI in October? Hint, hint, we're gonna have one in October. We'll start publicizing for it actually August 1. You can go through and attend it afterwards, see if there's funding involved through your school or through your state, and afterwards become a authorized coach in it, help to lead future workshops, which also come with monetary compensation, which also may lead into future curriculum development and future curriculum writing, etc. So a large opportunity that we try to give to any educator that are looking to grow the overall capacity or involvement overall in ITEA, Engineering by Design, with the STEM CTL for teaching and learning. Because you are a consortium state, the fees are substantially reduced, and essentially it's a workshop that's done over the course of a weekend, not infringing on the school week. It's a Friday evening, a Saturday, and a Sunday. And you do get 24 professional learning hours from it. If you're looking to take your school to the next level in regards to trying to go towards a large accreditation or international accreditation, I highly consider looking at the STEM School of Excellence. It's a way to accredit your school towards all the great things you already do. Not that you have to do anything quote unquote extra, as the kids say, but it's a way to go above and say, hey, this is what we've been doing. Be great to have this accreditation, be great to have it for our school. And you get a banner sent to your school, be asked to speak at the international conference next year. And hey, you might even be featured in your local news magazine, such as Salamanca High School did as well too. It's a great opportunity to get involved in. The application is hot, live, and ready. It's actually embedded directly within our, directly within the presentation as well too. Another professional learning opportunity that we offer is called microbadging. Microbadging essentially is a professional learning series that you can take, and right now we have two, one on safety, one on digital literacy via Google Classrooms. You can learn up to 10 professional learning hours for each full course or 1 hour per individual course. And the pricing is as follows: 10 sessions for $349 for ITA members, or $4.99 for 10 sessions for non-members or individual courses as listed. We offer them starting in August 1 of each year to hopefully launch our new edition coming out fairly shortly. It's a great opportunity to grow capacity overall. And again, it's also a good opportunity to get involved with going towards recertification or certification for educators. Our ITA conference this year is in Orlando, Florida, as featured at the bottom of a lot of the slides. Registration for it is open and ready for you to go through and register. It's a physical conference overall, with our theme being the STEL, or Standards for Technological Engineering Literacy, the role of technology and engineering in STEM education, keys to success. Located over there in sunny Florida. Single, double, triple, and quad rates are included directly on here, as well as our key ideas to help to drive the conference overall. Although the application to present has passed, you can still put in to actually go through and present for conference. Just send an email to itea@ita.org if you'd like to present, even though the deadline is passed. Again, itea@ita.org if you're interested in presenting at ITA's conference in 2022. If you have any further questions or comments related just specifically to me or engineering by design, feel free to fill out this form or send me a direct email as listed on that first slide at arnovitsky@ita.org. And if you'd like further information to ensure that you get access into your ITA content or engineering by design content, make sure you left click on that link. It'll bring you directly to your North Carolina site. Got to make sure you're logged in. Got to make sure that you click the little button that was over here so you can get access to resources. Left click accessing EbD curriculum. Left click on the consortium network agreement form, fill it out, and send it to your respective state consortium director, Ms. Kim Forbes, which I'll show on the next slide, or directly to me, and I'll coordinate with Ms. Kim Forbes for you. Or if you're looking to get to your consortium page for the PDFs overall, for access into them and seeing the individual courses by the PDF, then just navigate as shown before into the individual course via the PDF that's on your state page. If you'd like to get a trial of the Buzz, we give 1 or 2 KSBs within a course so you can try it out. It isn't full access, but it is temporary access to a snip of the course, a look and feel of a learning management system. If you would like further information in addition to reaching out to me, please feel free to reach out to Ms. Kim Forbes, your EbD State Consortium Director, at kim.forms@dpi.nc.gov, or to Ms. Nancy Hart, Affiliate Representative for ITA, at nhart@ita.org. Thank you for giving me the opportunity to present for your conference, and I hope to hear from you all soon, and I hope you have a wonderful summer. Thank you.